Hi everyone, welcome to our online learning. Okay, we thought we were done with the PowerPoints, but I guess not. So we're going to start chapter 10, which is data analysis, also called statistics. Okay, so first of all, we've got three types of studies that we're going to talk about. Sample surveys, this kind typically involve a questionnaire distributed to a group to determine, characteristics of particular attitudes. It might be as simple as asking school classmates about their favorite pets, or it might be as complicated as collecting something on the entire population of the United States. Okay, so it's just a sample, you distribute questionnaires. Then we have experiments where the researcher typically manipulates one or more variables, excuse me, to see any differences in outcomes. For example, we may be trying to grow seeds in a cup and vary the different amounts of sunlight or water or both. Okay, and then we have observational. It's basically like experimental, except we just do observational when it's like unethical to do experiments, like observing smoking, as it relates to health. We can't ethically ask someone, you smoke 2 packs a day, you smoke 2 cigarettes, you don't smoke. So this is where a researcher just observes how variables interact with one another with no manipulation by the researcher. Okay, let's see what we have next. Variability. Okay, much of the study of statistics deals with the variability of data, or the amount the pieces of data in a data set differ. For example, we have measurement variability. I'm sure we all experienced that when we were trying to measure and calculate the surface area of those little nets, right, on one of our activities that we folded up to do the surface area of our polyhedron. So measurement variability is simple human fallibility that produces different results. Okay. Experimental variability is different treatments cause different results, what we were just talking about in our experimental studies, where we actually use variability, in an experimental mode. And then there's sampling variability, which is where your selection of your data or the questions asked might produce bias. For example, what if you ask a question like, is soothing classical music more pleasing than loud rap? Right? That's a biased question. Instead of just saying, do you prefer classical music or rap music? Right? So sampling variability. Sample versus population. Okay? A population is the total group of objects or people involved. A sample is a subset of the population. Okay, so for example, what if we want to know about the food in the college cafeteria? So the population would be the entire WC students, staff, right, that could eat in the cafeteria. The sample would be only those particular people that we actually stopped and asked their opinion of the food in the cafeteria. So a random sample is one in which each member of a population has the same chance of being selected. For example, it would not be a random sample to come into this classroom and ask you guys which, how you felt about the food in the cafeteria, because students that aren't here for a elementary or middle school teaching degree will never take this course. So they would never have had a chance to have been selected in the survey. A representative random sample is a sample that's highly representative of the population from which it was taken. For example, suppose instead of this class, we went over to the nursing building and, asked some students in the nursing building about the food in the cafeteria. Okay, while it's also not a random sample because many of us don't even go in a nursing building, it also would not be a representative sample because maybe nursing students have different opinions about what they would consider, good dietary food for the cafeteria to be offering. Okay, if you have any questions about that, be sure to let me know. People sometimes deliberately use statistics to mislead others, and this can be seen in advertising and politics, right? More often, however, the misuse of statistics is the result of misinterpreting what the data and statistics mean. So we have to be really careful about these things. So consider an advertisement reporting that of the people responding to a recent survey, 98% said that Bufopain is the most effective pain reliever of headaches and arthritis. Okay, so the way these slides are placed, it makes it a little bit difficult to look at their answers, and I manipulated them a bit to help suit our needs, but they're still just not ideal. So keep this in mind. Okay, advertisement says 98% of people responding to a survey said that Bufopain is the most effective pain reliever. Okay, so suppose 1 million people were sent this survey, but only 50 responded. This would mean that there was only a 0.005, a 5,000th of a percent response, which would certainly cause us to mistrust the ad. So suppose of those 50 that responded, 49 were affirmative, that yes, it is great. So the 98% claim is technically true, but keep in mind 999,950 people didn't even respond. Okay, also suppose a survey sentence read, Bufopain is the best pain reliever I've tried for headaches and arthritis. But there were no other questions about the kind and type of other pain relievers tried. Okay, suppose all the people who received the survey were chosen from a town in which the major industry was the manufacturer of Bufopain. It's very doubtful that that survey would represent an unbiased sample. So remember that when we're talking about statistics and displaying them and interpreting and analyzing them, that there's certain information that we really need to know, right? The questions that were asked, the number of people that was actually surveyed or responded to the survey, okay? How the people who participated in the survey were chosen. Again, were these just people in the town where Bufopain has their manufacturing company? The number and type of pain relievers used, was it Bufopain versus a placebo? And everyone said, oh yeah, Bufopain is better. Okay. And how the answers were interpreted. So we want to keep those basic things in mind. Okay. Oh, look, here's another one. Suppose only 2 pain relievers were tested. Bufopain, whose active ingredient is 100% aspirin, and a placebo containing only powdered sugar. Oh, yep, something we'd already mentioned, but there it is. Okay, so there's the things actually that I already just went over to certify that the statistics are not being misused. We should have at least report the following information. Okay, give you a minute to read those, but that's the things that I just stated. Okay, so here's our examples. Which of the following might provide a random sample for a statistical study of cafeteria food choices in a school, and why? So a collection of students on the playground who do not eat lunch in the cafeteria. Okay, this would likely be a bias sample because the students are not eating lunch in the cafeteria and may not even know what's being served. A collection of students at a single table in the cafeteria. This would likely also be a bias sample, as the people who are eating together at a table may have influenced each other's choices in the cafeteria. Okay. Every fourth student entering the cafeteria on a given day. This could be a reasonable sample for the study as it has a degree of randomness to the students chosen. However, this set of students could be influenced by absences due to field trips or other school activities, biasing the sample. And once again, those students in the playground that we were just talking about that's not eating in the cafeteria wouldn't have a chance to be asked. Okay, every fourth student entering the cafeteria on a random day. Okay, this is probably the most random of all the ones given. So it's chosen on a random day and somewhat randomly. Okay. Still has the problem of not asking about anyone that never eats in the cafeteria, right? And perhaps that's the reason they're not eating in the cafeteria is because they don't like the food choices. Okay, let's see. Underlying issues. The following framework for statistical problem solving was suggested for the classroom. Formulate questions, collect data, analyze the data, interpret the results. Okay, so as noted earlier, when collecting data, there needs to be an awareness of avoiding biases and to choose as random a sample as possible, right? Also remember that when you're formulating your questions, okay? Avoid bias in how the questions are asked, okay? Analyzing the data. Well, later we're going to talk about analyzing the data and how we're going to display it and stuff, and the same thing for interpreting the results. Okay. Okay, for any given problem where data are needed to determine either an answer or an approach to an answer, it's important that the problem be clarified to the extent that meaningful data can be collected. For example, if we wanted to collect data on the appearance of an average fifth grader, we must clarify what it means to consider the appearance of an average fifth grader. Right? What do you mean by appearance? Do you mean their height, their hair color, their eye color, the kind of clothes they wear? Okay, what? Okay, evaluate the following questions describing any bias or other expectations if they were asked in the given school classes. So, first grade, do you have a pet? This is not a statistical question as it is deterministic. Okay, so again, the difference, not again, but I don't think we've mentioned this yet, the difference between statistical versus deterministic, right? Do you have a pet? That's just a yes or no question, right? There's no statistical analysis there. In grade 1, how many pets do you have where we've got some different data that we could gather would be more statistical. Okay, grade 4. How many good pets does each student in the class have? This could be a statistical question if the word good were eliminated. The word good gives a reason for biases in answers, as good is not really defined. Okay, what about 7th grade? Do students have more pets per student as they progress from grade 1 to grade 7? This is a good statistical question that could be investigated in a school. The next step is to develop a plan for collecting the data needed to answer the questions. An immediate question is from whom or where the data have to be collected. The context is most important. For an individual's health blood draw, a technician inserts a needle in a vein and takes a sample. Discuss this as a collection of data. Okay, answers will vary, it says, but assumptions are made that blood circulates throughout the body in a uniform way, and choosing any vein to make a blood draw should give a random sample of that person's blood. In a U.S. census, every individual is by law counted. Typically, interviewers collect data, discuss this as a collection of data. Okay, answers vary again, but a census is designed to poll the entire population of the country. In this case, there is no randomness involved in the collection, right? But because you're testing the entire population, right, it's the best kind of data you can get. You don't have to make inferences. Oh, there goes my phone, guys. Let me turn that off or it'll just keep ringing. It was my mama. Okay. In analyzing collected data, we must make a decision about how to display the data or whether to report numbers to summarize them. And once again, we're going to talk about this as what the rest of the chapter is going to be like. So it says, often decisions about how to analyze data will be made with the data in hand. However, a good plan for collecting data should include some consideration of how the data will be analyzed once it is collected, right? So think about, what your goal is while you're collecting the data. The results of data analysis must be interpreted. Some interpretations are clear-cut, others sometimes misuse data. The interpretation must be related to the original questions. Okay, decide whether each of the following questions is biased or fair, and if biased, why? What is your favorite subject in school? What do y'all think? Biased or fair? And why? Yeah, it seems fair to me. I don't see a problem with that. Okay, as opposed to B, do you enjoy the refreshing taste of ice cold soda on a hot day? Definitely biased. The question itself, has inherent influence built into the way it's asked, as opposed to just, right, do you drink soda? Do you like soda? Okay, suppose a poll is being conducted in an elementary school by interviewing 50 students. Explain whether or not the following samples are representative of the students at the school. The first 50 students leaving the cafeteria. I would say not representative. If you're talking about an elementary school, they usually go to the cafeteria by class, right? So if you're just doing the first 50 students leaving the cafeteria, they probably come all from the same class, all from first grade. What about the fourth graders and the fifth graders? They're going to have a lot different opinion. Not representative. 50 randomly chosen names from a computer-generated list of names of all students at the school. Yeah, if it's really randomly chosen from all students at the school, then everyone, whether you're first grade, second, fourth, fifth grade, right, has a chance of being selected. 10 students randomly chosen from each of the 5 areas of campus. Okay, if there are only 5 areas of the campus, and those 10 students are randomly chosen, that would probably be fine. 5 students from 10 teachers' classes. Well, we'll need a little more information on that. Are you choosing 5 students randomly from 10 teachers' classes? And were the 10 teachers randomly chose? Right? So just as it's stated, no, that would not be representative. For one thing, if you just let the teachers choose, 5 of your students for a survey or a questionnaire or something, teachers will likely choose their better students. Okay, and also perhaps the principal or whoever's doing the survey chose his 10 favorite teachers. Okay, that looks like that's it for this one. Again, just because it's the first section in the chapter, not really a lot of math, a lot of terminology and definitions and things. Just let me know if you have any questions. hopefully these will get better. All right. Thanks, guys. I'll talk to you in the next one.